Welcome to Chapter 2, Matter and Energy, part of McGraw-Hill Science for 4th grade in El Paso ISD. In this chapter, students dive into the physical world around them. They'll explore what matter is and how it behaves, and how scientists observe and describe it using real tools and measurable data. The big idea for this chapter is that matter is classified and described by its observable properties. These include temperature, mass, magnetism, relative density, and physical state, solid, liquid, or gas. By observing and testing these properties, students will begin to group and compare materials just like scientists do. Throughout the chapter, they'll shift from just observing to thinking scientifically. They'll ask questions like, what is it made of? How does it behave? And how can I test it? This shift in thinking is what helps students grow into confident and curious problem solvers. Now, this chapter is guided by 4 essential questions, one for each lesson. The first is how matter is classified and described by state and temperature. The second is how matter is classified and described based on mass. The third is how matter is classified and described based on relative density. And the last one is, how is matter classified and described based on magnetism? Each of these questions helps anchor student learning and understanding and ties it directly into the hands-on investigation. In Lesson 1, students explore how to classify and describe matter based on its state, whether it's solid, liquid, or gas, and its temperature. The common misconception is that gas isn't matter because we can't see it. Students also often think that a liquid amount changes when you pour it. Here, they'll learn that gases and liquids both take the shape of their container, but the amount stays the same, and both are indeed matter. In Lesson 2, we explore mass, which is the amount of matter in an object. Many students assume larger objects always have more mass, but that's not always the case. In this lesson, they'll understand how to classify objects based on actual mass using balance and digital scales, and understand that size and mass don't always go hand in hand. Lesson 3 introduces relative density, or the idea that objects float or sink depending on how dense they are compared to water. A common misconception is that floating depends on size or mass alone, but students will test and discover that it's about how dense something is. This lesson includes fun hands-on tests using classroom items in water. Finally, Lesson 4 focuses on magnetism. Students will classify materials as magnetic or non-magnetic. Many students think all metals are magnetic, but that's not true. They'll learn that materials like iron and nickel are magnetic, but others like gold and aluminum are not, even though they are metals. Each lesson in this chapter includes a hands-on investigation. Here's what students will do. Icy ice, measure temperature as ice melts. Balance and scales, weigh objects and compare their mass. It's all relative. Test objects to see if they float or sink. Test the objects. Use magnets to classify materials. To prep, teachers will need ice, cups, thermometers, scales, magnets, water, and a variety of small objects. Most materials are reusable or already in their classroom. Finally, in this chapter, it is important to understand that science and literacy can come together. Maglev Trains connects to magnetism and STEM careers. Independent readers like What Sinks and Floats, Gases Matter, and Strong as Steel support key concepts. The book Experiments with Heating and Cooling is perfect for Lesson 1, and Matter and Its Properties makes a great read aloud to introduce vocabulary and spark discussion before the chapter begins. Thanks for joining in this just-in-time video for Chapter 2, Matter and Energy. This chapter builds critical thinking, investigation skills, and curiosity. It encourages students to observe and question and explore the physical world, just like scientists do. We can't wait to see what learning and discovery happens in your classroom.